Hi, I'm Carl Host from the Lincoln Electric Welding School in Cleveland, Ohio. And today we're going to be doing some gas tungsten arc welding, or commonly called TIG welding, on some different materials, but we're going to be using a copper alloy filler rod. There's some benefits to using copper alloy for TIG welding. We can weld some materials together, bronzes, and also use some brazing on steel. So I'm going to show you a couple little tricks here. We're going to be working today with a Precision TIG 225. It's a 225 amp TIG machine, also capable of doing stick welding, but we're going to be doing TIG today. Argon shielding gas. We're going to be running about 20 cubic feet per hour on the flow rate. I'm using a PTA 17 air-cooled TIG torch. It's a 150 amp torch, and I'm using a number 6 nozzle on this torch. 332 2% thoriated tungsten. A 332 silicon bronze filler wire, and it's a copper alloy that has about up to maybe 4% silicon added to it, so it is a bronze, and we can use that to braze steel, join dissimilar metals. It can be used to clad materials for wearing surfaces, joining copper to steel. So we'll try a couple different things with this product, and we'll see what all we can do with it. First project I'm going to work on is some thin steel. This is 18 gauge steel, and that's pretty easy to TIG weld. I've used a 045 wire and already made a little bit of a weld here. That's a weld with regular steel wire, not the silicon bronze. But there's one little problem with that. I had to go pretty slow. I ran my current down around 48 amps, materials right around 48, 50 thousandths thick. And the weld looks pretty good, but if you look at the back side, you can see I have some burn through. And that's sometimes an issue with this. I mean, if you use a pulser, keep your current down low. Sometimes if you're real careful, you can avoid that altogether, but sometimes it's difficult to avoid the burn through on the back side. And if I want to weld a back on a fender for a car, something real thin, and I don't want this damage on the other side, sometimes brazing is the answer, and you can TIG braze. You can't use regular brazing rod because it has a lot of zinc in it, but the silicon bronze will work. So silicon bronze filler wire melts a little over 1700 degrees, and of course the steel melts around 2800 degrees, somewhere in that range. So what I'm going to do is heat this steel up to the temperature where this bronze will take to it, and I'm going to run a little higher current than I did here, but my travel speed is going to be significantly higher. And you can see my heat here, and you can see the heat I had in the back, but hopefully we're going to get that heat input down and no melt through on the back side. And this will still be an adequate strength weld for what we're working with here. It's pretty thin steel. Anytime you're doing arc welding, or any kind of welding for that matter, you should always make sure you have your appropriate safety protection gear on. And I always wear a pair of safety glasses under my welding hood, gloves, long sleeve, fire retardant shirt, and make sure we have adequate ventilation for the process we're using. Okay, I'm going to be welding with a silicon bronze 332nd, pretty good sized wire, and remember it melts at a lower temperature than steel, so I'm going to run my current pretty high but keep the heat on the weld metal, on the bronze. And I'm basically going to be brazing. I'm not going to melt the base metal, I'm going to bond this bronze to the base metal. Traveling pretty quick, I should be able to keep my heat input down some, keep the distortion down also. All right, here we go, cover up. You can see we have a gold looking weld there. Little bigger leg size on the weld. This material is not quite as strong as steel, so we're not really welding. It's really kind of a brazed joint, brazed welded joint. But you see here we don't have the damage or the burn through on the back side. Little less heat input, a little bit less on the heat input because we traveled a little faster even though I ran more current. So sometimes that's used to limit distortion on jobs because you can run lower current. You can also they do what's called MIG brazing, where they use a MIG welder and use the same filler metal but smaller diameter with a gas metal arc welding machine. Sometimes it's used for non-structural or seam welds on automotive applications where they want to seal something up and limit the heat input. So it makes a nice looking weld. Multitude of uses for this wire. Sometimes when you have something really thin to join, a small wire to something that's a little thicker, and you have trouble with burning that wire away, using a silicon bronze is a good way to bond it. Artists working with bronzes, coppers, I can weld copper to steel with this wire, copper to stainless steel with this wire, or bond them together. I guess you would call that a braze weld. I'd want to caution, I wouldn't weld a roll cage for a car with this. I wouldn't do anything structural like a bridge using this process, but maybe a set of bookends for your office. It makes a nice, attractive looking weld, artistic purposes. There's some motorcycle builders that have built custom motorcycle frames, and they would weld them with steel wire, 70S2 or 70S6 wire, and then go over it with the bronze just for the look, because they're clear coating the frame natural steel color, and they want gold welds. So it's just a lot of things they use this for. My next project, I'm going to weld a little bit of copper to steel, regular steel, copper together, join the two together. Copper melts around 1900 degrees up in there, and the bronze melts at a little lower temperature, but probably melt into that copper just a little bit. But I'll show a little weld on that. Technique I'm using, again, I'm going to get some heat into this base metal. It's going to take quite a bit of heat to get this copper going because it has a lot of thermal conductivity, but once I get it hot, it's going to weld pretty good. But I'm going to try and concentrate my heat on my filler metal and my weld and not pick up too much base metal. I don't really want to melt that base metal. And I want to move along pretty quick once I get it going. I have a little thicker piece of steel here on the bottom. This is about 120 thousandths thick, so I turn my current up some. I'm up about 130 amps. Might not need all that. I'm going to adjust it with my foot pedal, but need a little more current for this thicker steel, and plus that copper is really pulling the heat up too. So I'm going to make this weld, concentrate my heat on the base metal, not so much on the base metal, more on the filler metal, but I want to wet into that base metal. I want to make sure I'm hot enough to tie into that base metal. I'll dab and move. Move around the corner here. I might as well run right around this thing. That piece is hot too. As that piece gets hotter, I got to cut back on the heat. That copper gets saturated up with heat. It doesn't need as much amperage anymore as it did before. So the steel we welded on today was a cold rolled steel. The mill scale had been removed from the steel maker. A lot of steel is hot rolled and has mill scale or surface rust on it, and that should all be ground clean before you weld. In this case, we had pretty nice clean steel, so we didn't need to make any special cleaning arrangements there. Afterwards, a good brush job will make that appear really nice shine to it. And if you're going to leave it as it is, in other words, you're not going to paint over it, you want that bronze to show up, a clear coat will keep that color, that gold color in the bronze. If it's for architectural or artistic purposes, you might want to keep it gold. There's a number of different copper alloy welding products available from Harris Products Group, and they're a subsidiary of Lincoln Electric. There's aluminum bronzes, phosphorus bronzes, which are tin bronzes, and they all have different uses, specific applications. You know, sometimes for bearing surfaces, an aluminum bronze is harder, so bushings and pistons are overlaid with that. Propellers for ships are often made out of bronze. So for more information on welding, go to lincolnelectric.com.